The next topic I want to start talking about is version control. Now, in an agile software development environment, as we kind of saw when I introduced this whole module, there is a lot of code modification and code extending going on a very, very regular basis. You know, if you're in the middle of a project and you've been asked to, implement a method of a class or implement a class, and you've been given a specification for it, it may require you to make some changes to other code so that your class can fit into the rest of the code base. And if that other code may not have been written by you, but you have the authority to make changes to other code. You can't have a situation where if you want to make a change to another class, you have to find the person that wrote that class and get them to make the change or ask their permission or anything like that. That just wouldn't work. So anybody really can make changes to any part of the application code base. That's taken as read really in an agile development environment. And that can be a recipe for disaster if you think about it, because people might introduce bugs accidentally to other people's code. So we need a way of tracking exactly who has been making changes to which particular parts of the code base, because the code base is evolving so quickly. And this is what version control tools will do for us. They will essentially record all changes that have been carried out by whom and when to each code unit in your code base. So they're called version control tools or source control management tools. And maybe the second name is a better reflection of what they do, in that they manage they manage and control the changes that are happening to the source code within your project code base. Now, there are a number of version control tools out there, but easily the dominant one today anyway is Git. And in the screenshot here, there is actually a free online book. I'm just giving you this as a reference, really. I don't expect people necessarily to go reading through chapters of it. It's just a reference point if you want to find out something specific about Git that I haven't covered and you're just interested in it. This might be a place to go looking, apart from Stack Overflow, obviously. So it's purely a reference. So what is version control? I'm saying it's a system that records changes to a set of files over time so that you can recall specific versions later on. And really, even though we use it in the context of application development, it's really anything can be in the file. It can be any type of text file. It could be a documentation file, could be a JSON file, could be XML, it can be anything. It's just, as long as it's a text file, then it can be put under version control, as we say. And as I said at the outset, really all the version control tool does is it records changes that have happened to a file over time. And it actually allows us to rewind a file back to an earlier state if we need to do that. So it allows us, I'm saying down here, it allows us to revert a file back to a previous state, or indeed to revert an entire project's set of files, an entire folder of files, or an entire project can be rewound back to an earlier state. It allows us to compare the changes that have been made to a file over time. Number 4, it tells us who made a change to the file, when it was made, and what particular part of the file did they change. So it really is very granular. And it's obviously very useful in terms of bug tracking. If a bug is introduced into, or if your application crashes, you find out, well, what changes have happened since the last time we ran the application. And the version control tool will tell you exactly what parts of the code base have changed, who made the changes, and where exactly in the files did they make the changes. So it's a very good aid to bug tracking and debugging. And really, the very last point there at the very bottom, even though a version control tool is very useful for you when you're working on your own on a project, because we can lose track as well of changes that we've made to files when we introduce bugs into our own code. But certainly when you're working in a project team, then it really aids team collaboration, because I said at the beginning there that in a team-based software development environment, really anybody within the team has the authority to make changes to any file. And so that aids, that facilitates kind of collaboration between team members. And so version control tools are really important in that kind of team environment. Now, this is more general now. This is not Git specifically, but there are kind of two designs to these version control systems or these version control tools. One is the kind of centralized version control model, where if you look at the diagram on the right, you have a server, and it's the server that's actually managing the version control system for you. And it kind of has the master copy, if you like, of the project code base. And individual team members, then what they can do is they can get a copy of a particular file or maybe folder from the server, make the changes, and then push their updates back to the server. But the idea with this centralized system is that there is only one kind of master copy of the entire project under version control. It is centralized. And obviously, one of the disadvantages to that model is if the server goes down, then nobody in the team can actually access it. The earlier version control tools followed this model. So, for example, the CVS tool and Subversion were all based on this kind of centralized model. And the disadvantages are what I outlined there. Oh yeah, well, just in terms of terminology, we talk about the repository. So the repository there on the left, that's our server. That's our master copy, if you like. Let me just bring up my pen. So the repository is the project code base that is under version control. And then you have your individual team members, and what team members, what they can do is they can check out. Sorry, yeah, they can check out parts of the repository, individual files or folders. So we talk about checking out from the repository, and so what they get is they get a working copy of a particular file or folder from the repository. They make changes to it, and what we say then is that they commit their changes back to the repository. And when the commit request comes to the repository, the version control software, which is running here, takes care of making the necessary changes to the repository. So this idea of checkout, commit, these are terms that we use when we're talking about version control systems, whether it's the centralized model or not. And when we use the term working copy or working tree or working directory, that's where an individual team member can actually carry out edits on a file or set of files. That's just some text on the previous slide. The alternative structure for your version control system is a distributed model. And in the distributed model, the idea is that each team member on their own personal computer has a full copy of the repository. Okay, and the version control software then actually is distributed across a number of computers, and the version control software will take care of ensuring, well, if the team member working on this computer makes some changes to files and updates his or her local repository, then the version control software will tell the other computers on the network about the change that has happened to this repository. So it keeps all of the repository copies in sync. You don't have to worry about that. The version control software, which is distributed across these nodes, will take care of that. And so that's nice in the sense that every team member now has their own local copy of the repository, the full repository. They still have to carry out this checkout and commit kind of procedure. You don't make changes to files in the repository. You never do that directly. You still have to check out files or folders from the repository, do your editing of those in your working area, and then commit the changes back to your local repository copy. And once you've done the commit, as I said, the version control software will tell the other nodes about the update that has happened to this repository so that all of them are kept in sync. And it's, in a sense, that's how Git works. And there are other version control tools that work like that as well. Now, we will actually be using Git kind of in what I'm calling a kind of private mode, where we will have a Git repository which we created ourselves on our local machine for our local project, and we'll be working completely in isolation. We won't have this kind of distributed Git model. Git kind of runs in two modes. It runs in distributed mode and it runs in standalone mode. We will be using it in standalone or private mode. Now you may ask, where does GitHub come into the picture? And really all GitHub is a cloud service that allows you to make a backup copy of your private standalone Git repository. That's how you can kind of think of it. It's not so much this distributed model that I was explaining in the previous slide. So in the labs, you will be using Git in this kind of standalone private mode. Later on in the module, we will be using GitHub. But as I said, GitHub is really just only a means of making backup copies. It's a bit more sophisticated than that, but essentially that is all it is, a backup mechanism. So if I have got a software project that I'm developing on my own machine, and I have a Git repository associated with that project, this is how it actually will look on your file system. And this is what we do in the labs associated with Git. I'm going to reuse that product catalog little mini project again for convenience. And it's going to have, and I'm going to be using Git to perform version control on my product catalog project. But what I'm showing you on the screenshot here on the left is when I actually create a Git repository, then it actually appears as a physical directory within my project folder. And the directory on the top left there is called the .git directory. So that is the actual repository. On the right, I'm showing you if we expand out the contents of that .git folder, that's what I'm showing you on the right. And that is the internals of the Git repository. Now, in the vast, vast majority of cases, you never worry about what is the internals of your Git repository. And in fact, it could be quite dangerous to go looking inside the internals of the Git repository, because if you accidentally make a change to any file in there, then you potentially corrupt your Git repository, and it's very difficult to actually recover that corruption. Now, having said that, though, I will actually look at the internals of the Git repository with you later on, just to show you some ideas to how it works kind of internally, which I think is kind of interesting. But in the vast majority of cases, you never go near the internals of Git. You interact with it via the command line in terms of doing Git commits and Git checkouts, etc., etc. So physically, that is what a local repository is. And I'm saying down here as well, like that, you always have to have your Git repository in the base folder of your project. What else am I saying? Everything inside the base folder except Git is, oh yeah. All of the rest in your, all of the rest of the files and folders in your project is really what we would call our working area, our working directory, or working tree. These are the things that we can, edit and make changes to and create new files, etc., etc. And these are the things that we commit to the Git repository, as we'll see maybe later on. So I'll finish on this slide. So I've got this project and I want to maintain a Git repository in parallel with it. And so the steps simply are, you go to the base folder of the project, and your project now at this stage has some files and folders in it initially. And if you type that command from the command line, what that command will do is it will create the .git subfolder. In other words, it's going to create an empty repository. Empty in the sense that it has no copies of our files and folders, but it has lots of stuff already in it. And then we typically, we commit the initial version of our project structure to the repository. And there are two commands that you need to submit in order to do that. So when you've submitted these two commands, what we now say is that the repository has the initial or version of your project files and folders. And that's kind of your starting point. And from then on, we start making edits to our files and updating our repository. And I guess, so you create a Git repository for every project that you're working on, and the Git repository is local to that project. Physically, a Git repository is nothing other than a folder in the project itself. And if you expand that folder, you can see what's contained inside the folder on the right. So even an empty Git repository will have all of those files and folders that you see on the right there. As I said to you the last day, really, you never need to look at the actual files and folders inside in the Git repository. Although I'm going to break that rule at the end of this lecture, towards the end of this lecture, and do look inside it, but you shouldn't really. You're definitely interested in what's inside in the Git repository, but you use the command line interface to discover anything you want to discover about a Git repository. So number one point now is we have a Git repository for every project that we're working on, and the physical location of that Git repository is it's in the base folder of the project itself. So how do we create a Git repository? It's a simple command, the git init command. You must submit that command from the base folder of the project. And when you do that, then it creates the .git folder that I showed you on the previous slide. The repository is still empty at this stage in the sense that it has no knowledge of any of the files in your project. So the next thing you do is step 2. Now there are two commands that you have to submit. We'll talk about the difference between them later on, but the effect anyway of submitting these two commands is that you have now copied the initial version of your project into the Git repository. And if I go back to the previous slide, so having submitted those two commands, essentially now everything here has been copied into the repository somehow. It isn't a case of just taking these individual files and folders and somehow moving them into somewhere inside here. If you looked inside here, for example, you would not find a physical file called package.json. You would not find a folder called src. So it doesn't store them that way. We'll see later on how it does store them. But the effect anyway of making a copy of your, we refer to this as the working area or the working directory. So the effect of these two commands is to make a copy of your working directory, your working area, and making a copy of it inside in the repository. So the repository now has, we could say, the very first initial version of your project. So that's how you get started. Now, there are lots of version control tools. Git is only one of them. Prior to Git, version control tools, the way they actually stored your project internally differs from how Git does it. So what I'm trying to illustrate here is, supposing we've got a very simple project and it just has 3 files in it. So when we store the initial version of our project inside of the repository, then this is a representation of what the repository now has internally. It has a copy of file A, file B, file C. Then we come along and we make some edits to file A and file C. We make the edits in our working directory, and then we commit those changes to the repository. What do I mean by we commit them? I mean, we simply submit these two commands again. We use a different message. I'll come back to the message later on, but we submit those two commands. And having submitted those two commands, the Git repository has now been updated, and the update looks like this. So what version control tools prior to Git did was they recorded what changes have happened to the files. So these are deltas. That's how they worked. Okay, so they have the initial version of the files, and then they record what changes have happened. And then I continue on working. I make some more edits. So it looks like I've edited file C in my working area, and then I commit it again, and on we go. So these version control tools, this is not Git now, but the other ones, this is the way they worked. They actually stored the changes that have happened to files over time. Now, the way Git works, though, is different. This is how Git actually would store your changes over time. So again, we have the same starting point, and I've then gone and made changes to file A and file C. And I committed those changes, and this is what Git does. It actually makes a completely new copy, or it stores a completely new copy of file A and file C internally. It doesn't make a complete copy of file B because that hasn't changed. Although what it will do is it will somehow record a pointer back to this version of the file, indicating that it hasn't changed. And then it keeps on going in that way. So every time you commit changes that you have made to your files and folders in the working directory, what Git actually does is it stores a complete copy of the changed files internally. Okay, so it's very different from the way other version controls tools work. And it keeps references to earlier versions of files if they haven't changed. Okay, that's a very kind of high level explanation of the difference between Git and version control tools. Now, what's next? So I'm talking there about the working directory a lot. So the working directory is really what you see in your editor. So for example, in the case of the product catalog project, these are the various files and I can make edits to them. Now there is a .git folder inside in this project. It's not being shown by VS Code because you never want to do any editing on it. Although if I do a dir here, or sorry, ls in my case because it's Mac. If I do an ls -a, then you can see there is a .git folder inside in this folder here. So there is a Git repository. So this is what we call my working directory or my working area. Now, in the slide, I'm saying as you work through a project, you'll always, every now and again, want to know what is the status of your working directory. And essentially, there are 3 states that your working directory can be in. Number 1, it's in a committed state. What that means is you have made no changes to any files or folders since your most recent commit. Right? Or to put it another way, the Git repository and your working directory are completely in sync. The Git repository has the most up-to-date version of your working directory. The second possibility we're calling the modified state. What that means is you have committed, you've made a commit to the repository, and then subsequently you modified some files, maybe created some new files. So now we would say that the working directory is in a modified state. In other words, the Git repository and the working directory are no longer in sync. The Git repository is slightly behind. The third one then is a kind of an odd one really to explain, but the way we explain this idea of staged is to say that you have made changes to files in your working directory. You've told Git that you will commit them, but you haven't committed them yet. Now it's kind of the odd one out really, and it's not as tangible as 1 and 2. But if you want to think about it this way, we saw in the earlier slide, if I just go back again, I said you've got to submit these 2 commands in order to update your Git repository with whatever changes you've made to files. Now, if you only submit this command, then what we would say is that your working directory is now in a staged state because the effect of this command is to somehow tell Git that you will do a commit sometime in the future, maybe immediately or maybe not, but at least the effect of this command is to tell Git that I will do a commit. It also has the effect of telling Git, or at least when you submit that command, what Git will do is it will keep a record internally of what files have been changed. It won't necessarily record the full changes. I'm going to explain it like that for now anyway. We'll see the detail of the difference between these two commands in a minute. So it's a bit vague, I know, this idea of staged, but for now, we just have to accept it as staged means you have told Git via this command that you have made changes to some files. Maybe you've created some new files. You've told Git about them, but you actually haven't committed them yet to the repository. This is your typical workflow when you're using Git, and this is really what you would have been doing in the unit testing lab, and indeed in the web app development labs as well, I think, actually. So initially, anyway, you create your project initial folder structure. So you might know what your folder structure will be for whatever project you're working on. You may have some initial configuration files like your package.json if it's a JavaScript project. You may have some initial source code. So you have your initial kind of project or working directory set up. The next thing you do is you create your Git repository using the git init command. Then you've got to stage and commit the initial project structure using these two commands that we've been talking about. So now at the end of 4, the Git repository has a complete copy of your initial project structure. Number 5 then is you start doing some development. And after a certain period of development, you decide, I'm actually going to commit all of the changes that I've made to date to the repository. So you essentially repeat these two commands. So the Git repository now has 2 versions of your project, the initial one and the updated one. And you continue on in that vein. You continue on between 5, 6, and 7 as you work your way through the project. So every time you do step 5 and 6, if I might go back, every time you do step 5 and 6, you are essentially adding another line to this log or this history of your project, and you're adding it to the actual Git repository. That's your typical workflow, although we'll see a little bit later on that the whole area of branching, which I'm mentioning there down at the very bottom, the whole area of branching comes into this workflow as well. But for now, we're not concerned about branching. Now, what this means is that as you're working your way through a project, at any particular point in time, the status of any one file could be in any one of these 4 different states. So this is a slight now expanding of the status of the working directory. We're now down to the status of an individual file. And when I'm talking about the status of a file now, I'm talking about the status of a file in your working directory. And it's Git's understanding of the status of a file. This is all relative to Git. So from Git's point of view, a file in your working directory could be in any one of these 4 states, and it will actually be able to report that to you. So let's talk about them briefly. Number 1, I'm saying a file in your working directory could be in an untracked state. What that means is that you've created a new file. You're in the middle of your development now. You've done a number of commits to the repository, and in the middle of your development, you create a completely new file. Now, Git actually doesn't know anything about that file so far because it has no previous record of it. The term we use for that type of file, or for that type of file from in terms of Git language, is we would say the file is untracked. Number two, supposing you have a file and you have committed it in an earlier commit to the repository, but you've now made some change, or sorry, you have committed it in an earlier commit and you haven't made any changes to it since, then what Git would say is that that file is in an unmodified state. Number three is you have a file, you have committed it in an earlier commit to the repository, but you have modified it since and you haven't committed those modifications to the repository, then from Git's perspective, that file is in a modified state. And the fourth one then is always kind of the odd one out. You have a file, you have committed it to the repository in an earlier commit. You have made modifications to it since your last commit, and you have told Git that you will commit it by using the git add command, but you haven't committed it yet. That's what we refer to as being in a staged state. So it's a bit like the earlier slide, really. 1, 2, and 3 we can make sense of. 4 is still probably a little bit vague, but you'll have to get used to that vagueness, really, for now anyway. So there's this notion of tracked and untracked files, modified, unmodified, and then staged is kind of that edge kind of case. So that's from a Git's perspective, any particular file in your working directory could be in one of these states at any point in time. And this diagram shows in very kind of graphical terms how a particular file moves from state to state over time. You know, initially, if you create a new file, it's untracked. Then if you commit that file, now it's tracked and it's unmodified. Then you make some changes to it. Now it's in a modified state. Then you commit those changes. So now it's back in an unmodified state, and on it goes. So the diagram there kind of explains how you move from one to the other. Some people like the diagram, some people just take the English kind of explanation to be a little bit clearer. So that diagram there is really a reflection of what is being said on that slide. Maybe to try and illustrate that, if I just flip over to VS Code. So here's my little product catalog, and I have done a number of commits now to the local repository. And what's really nice about VS Code is that it has really great Git support. And the Git support is mainly behind this activity here. Now, what I can tell from just looking at this is that all of my files are in a unmodified state. In other words, I've done a commit recently of any changes that I've made. So now the repository, the Git repository, is completely in sync with my working area. But if I make a change to a file, so it doesn't really matter what I'll do, just make an edit to it. And I save, oops, that's it, sorry. And I save that change. Look what's happened over here actually. VS Code is telling me behind the Git activity that there's one change in your working area vis-a-vis the repository. And if I actually click on this here, it's telling me what the way I interpret this is that this file, N there stands for modified. This file has been modified since your most recent commit. That's true. I have modified it. If I go in, create a completely new file, I'll just stick it in here. It doesn't really matter. And now VS Code is telling me there are 2 changes to your working directory. And if I look at the detail, the way I interpret this, the U here means untracked. This is an untracked file, i.e. you have never committed this file to the repository so far, and that's true because I've just created it. My repository has lots of commits to it, but this is a completely new file. It's an untracked file. Now, where does staging come in here? So the way I interpret this from VS Code's point of view is these 2 files are changes in your working area since your most recent commit. And if I do a git add, the -a there means I want to stage everything, A as in all. So if I hit return and watch what changes over here now, if I hit return, what this is now telling me is that these 2 files have been staged, i.e. when you submit a commit next, these 2 updates will actually go into the repository. Still maybe a bit vague, but anyway, that's, you see, when I do a commit, let's do a commit. And don't ever do this now. Commit messages should always be meaningful. But notice here in the git commit command, I'm not specifying any files to be committed. So how does Git know what files you are committing? And the answer is you told it in the previous command what files you are committing. Okay, so that kind of throws a little bit of light on this idea of the difference between staging and committing. We never specify in the commit command what particular files we're committing. So how does Git know? Well, you tell Git what files you want to commit by virtue of the git add command. You may ask, why did the designer of Git decide on that? I don't have an answer to that, but that's the way it is anyway. So it's kind of a 2-step process rather than a 1-step process. Maybe because committing stuff to a repository is a kind of an important step, and you've got to be sure that you are committing what you want to commit. So by forcing you to do it in 2 commands rather than 1, forces you to think about it. As you would see later on, you don't have to say -a here. You could specify particular files that you want to commit. I can illustrate that. I don't want to do the commit. Everything that you do from the command line, you can really do over here. As beginners, I think it's probably better that you get used to the command line. But I suppose I've been playing with Git for quite a while, so I know, and VS Code, so I know how to use this interface to do what I want to do. I can actually I can undo this staging. Supposing I've decided, actually, no, I don't want these to be committed the next time I commit. So I can actually reverse the staging by just clicking the minus there. So you can see now my two files are back into ordinary, modified, and untracked. They're no longer staged. Oh yeah, so I can actually, rather than commit everything, I could do something like this. Or sorry, rather than stage everything, I could do I can stage particular files, and I could list other files along. I could list other files along this command line. So if I hit return, see what's over here now. This file now is in its staged state, but temp is still just ordinary untracked. Well, that doesn't actually reveal it anything. But if I now do a commit, all that is going to be committed is this file. This is not going to be committed because I have not staged it. So when you're working in a large project, you may be making edits to many files, and you've decided, I actually want to do a commit now, but I don't want to commit all of the changes that I've been doing. I only want to commit some of them for whatever reason. So the git add command actually allows you to specify exactly what files you want to have included in the next commit. I'm just going to undo this again. Just to follow on with this interface. If I want to stage everything here, what you do is you hit the plus there, and that moves them all into the staged state. Minus removes them all. You can remove individual ones. So I decided maybe I don't want this to be committed. So I'll just remove it from there, and you can see. So you can play around with that with a project that isn't too important. Maybe the unit testing project that you submitted there yesterday. You're now free to kind of play around with it from a Git perspective. Right. Yeah, oh yeah. So the git status command is the command that you would use to from the command line to find out what is the status of your working directory. Some people often get confused about this. Git status will report on the status of your working directory. It doesn't report on the status of the repository. Okay. Now, if you get very comfortable with Git within VS Code, then essentially you've got the status information here. But if you only work from the command line, then if I do, actually now what I'm going to do is I'm just going to go back to that. If I type git status here, then it's going to give me the status of my working directory. And it's obviously a mirror of what's over here now, but you should get used to interpreting the command line response as well. So it's telling me these are changes that are not yet staged. It's telling me that this file has been modified, which indeed it has. And it's telling me that this is a new file. It's a completely untracked file. Okay, so this is a long-winded report on the status. This is obviously telling us the exact same thing in a more graphical way. So that's the git status command. So you either use it from the command line or you interpret it over here, whichever. Obviously, this is much nicer interface once you get comfortable with VS Code's Git support. So that's git status. as a command line. I'm kind of painting a scenario here. Supposing I've ran git status and it's telling me this. So I've got 2 modified files and I've got 1 new file. If I then go along and do a git add -a and type git status again, I'm now told that all of these files are changes to be committed. That's how Git kind of expresses it here. But changes to be committed is the equivalent of this staged state. So if I want to do that myself from the command line here, if I do a git add -a, now just keep a kind of a snapshot of that in your head. This is what it's telling me the status is now before I do the git add -a. If I do the git add -a and then ask it for the status again, you know, it's now telling me these 2 files are changes to be committed, which mirrors what's over here. Okay, so git status is a very useful command when you're doing a lot of editing and you're trying to find out what have I actually been doing in terms of file changing and creating new files since my last commit. The git status command will tell you that. Although if you're comfortable in VS Code, you can also get it from VS Code's Git support. And just to finish that scenario, so I've did the git add -a and then I've done a git commit. And now when I type git status, this is the kind of response that you'll get back. It's telling you essentially that you've nothing to commit. Your Git repository and your working directory are completely in sync. Let's finish that scenario here. So if I do a git commit now, git status again. I'm on a different branch now, as it turns out. I'm not on master, but this is the important thing. Essentially telling us that our repository and our working directory are completely in sync. And if we look over here in terms of VS Code, you know, there's nothing here at all now. And that is as we had expected. Okay, let's get status. Caveats to the above. I've kind of already mentioned that you can specify particular files when you're doing the git add. The git add again is the staging, so you can be more fine-grained in terms of staging. The commit message is really important for yourself, really, as much as your teammates, but definitely if you're working in a team and everybody is doing their commits to the project. Let's ignore for the fact now that I'm just running Git on my local machine here. But in a more general case, if you've got a project that a number of people are working on and they can all commit to the repository, then the commit message is really a form of communication between the team members so that they have a sense of what happened between one commit and the next. The commit message should really be a succinct statement of why somebody made a commit to the repository. You would never specify in the commit message what particular files you changed, because you can get that information from other parts, other Git commands. The important thing when you're doing a Git commit is to try and express as succinctly as you can just the nature of the changes that you are committing, which is what I'm kind of saying here. Try and specify the why part. So the why part might be, I'm fixing a particular bug, I'm adding a new feature, I've done some refactoring on a particular feature, I've added some tests to a particular area, etc., etc. And I'm saying here, if you want to, if you want to find out, well, what changes, what particular file changes happened in a particular commit, then there's this other command called the git log command, which we'll look at in a while, which will give us that kind of detail. And in the bottom there, I'm saying that many software houses actually have rules and regulations as to how you structure your commit messages. Your commit message can be more than just a single line. You can actually, with the git commit command, you can associate a text file with the git commit command, and in the text file, you would have a full explanation of the nature of the commit. So many software houses would actually stipulate how you should format that text file containing your commit details. So it is really important, and it is really primarily a means of communication within a project team. Don't commit everything. You should not commit files that were generated by some tool or that you downloaded as a third-party module. So for example, in relation to JavaScript, all of the stuff that is inside in the node modules folder, they should never, ever be included in a repository, because it's in the case of JavaScript anyway, all of that information is in the package.json metadata file. So never commit generated files like log files or .class files in the case of Java. Never commit third-party libraries. Never commit, number 3 there is never commit files that are more linked to the particular IDE or text editor that you're using, because they're not really relevant to the core source code of the project. Now, how do you tell Git to ignore certain parts of your working directory? You do it in a special file called the .gitignore file. So it will express in a simple declarative way to Git as to what files and folders it should completely ignore. So I've made a reference to the node modules one there. That would be the highlight one for any kind of JavaScript related project. On the bottom right there, I'm showing you, so in your working directory, this special file called the .gitignore file, that has to be located in the base folder of your project, as you can see it there. Inside that file, you can specify file names and directory names, but there's also a certain amount of wildcard characters that you can use as well, and I'm just mentioning some of them there. It's kind of it's a subset of what are called this regular expression syntax, if you've come across that before in relation to searching in the area of programming. So here's a kind of typical gitignore file. And you can go back and look at the previous 2 slides now, but in the Git, it's just a text file really, but in the gitignore file, if a line begins with a slash, then that is telling Git that you're specifying a directory that it should ignore. And so we're telling it, ignore this directory. This line is telling Git to ignore any file that has the .log extension. This is telling it to ignore any file in the public folder. This is qualifying the one just above it though. The not there means it should not ignore HTML files in the public folder. This is just a specific file that we're telling it. The /* means in any folder or subfolder or subfolder all the way down, if you find any file with temp in its name, then ignore that. So the /** there is indicating that it should search through all subfolders and ignore anything with temp in the name. So that's just an example of a git ignore. It is extremely important that you get the git ignore right initially, because if you, for example, if you left out the /node modules in your git ignore and you did your very first commit, it's now too late because all of your node modules are now inside in the repository. So you've got to be very careful before you do the very first commit. Check that by using the git status command, really check that you are not about to commit stuff that you shouldn't really commit. This is in the very first commit now. You may change git ignore in the middle of a project as well, and that's okay. But make sure essentially that you don't, or put it another way, if files get into the repository that shouldn't, then it's too late. You can't kind of undo that. And I can kind of illustrate this to you, right? So here's my git ignore for the product catalog. Now, supposing, and I've done a number of commits now already, so nothing in node modules has been committed, but supposing I did something silly like this. I'm going to delete this from my git ignore, and I've saved it, and suddenly over here, VS Code's Git support is telling me that there are over 2,000 files that are now in an untracked state, and they will be included in your next commit if you stage them. And of course, those 2,000 plus files are all coming from the node modules. So if I did a git add -a and git commit, these 2,000 plus files are now inside of my repository, and I'm kind of caught really from here on in. Now, I don't want to do that, obviously. If I undo that and save, then I'm back to where I was. So for you guys, I guess the two most important folders are the /node modules. There's also a VS Code. VS Code sometimes creates a configuration folder in your project, and the name of the folder is .vs code. So you can see here I'm including it actually. You should include that as well, but also include other stuff that might be particular to your project that you should not have in your repository. So let's git ignore. Something that you'll want to do every now and again is you'll want to find out what's the difference between the status of a particular file in my working directory versus its most recent commit in the repository, or what's the difference between a file in my working directory at the moment and what I've staged recently. So the git diff command will do that for you. And I've got some examples of how you can use the git diff command. Now, not surprisingly, the git support in VS Code will do all this for you as well. And it's either or really. You either get used to the commands that are shown on that slide there, or you get comfortable with what VS Code can do for you. So again, if I illustrate it, if I again make changes to a file randomly, just repeat what I did a while ago, I guess. Okay, and go back to here. Now, if I click on the file, you can see here it's showing me, I think on the right is what's in your working directory. On the left is what was in your last commit. And indeed, you know, this is the difference between the two. And if you had other differences, you just scroll down and find out where they are. So this particular diff is the difference between your working directory and the last commit that included this particular file. That's what's being shown here. So it's the equivalent of this one here, right? But you can also, there are other variations of it as well. If you want to find the difference between, well, you can read the difference between the working directory and staged. You know, that's kind of peculiar, really. If I stage that, change, but then for some reason, I go back into the same file. Just want to close that off now. I go back into the same file and I make some more changes, even though I've staged. I'm just going to repeat this one, let's say. So I have staged this file, but now I've gone on and made some more edits. And you can see here, right, that the same file can be in the staged state and in the modified state. That's a difficult one to get your head around now, I'll be honest, but it's possible anyway. And if I did a git commit now, what would be committed is this. So in other words, the changes that I made here would not be committed. Now, having told you that, I think it is a kind of an advanced really aspect of Git, but maybe you've grasped it. Anyway, git diff is obviously useful to you because, you know, if you're doing a lot of editing, you may lose track of, well, what changes have I actually made to a file since I committed, and the git diff will help you with that. The git log command then tells you, gives you a history of the changes that have been made to your repository. It's a log of the commits, in other words. So if I just type it from the command line. Okay, so these are commits that I've made to this, and there are more. It hasn't finished here. So if I just keep hitting spacebar, I think it'll scroll on to the rest of them. If you want to exit out of this, you just type Q. Now that's fine, but of course the VS Code's Git support gives you the exact same kind of information, and it's this icon here. If I click on that, then I get the same kind of stuff. And what's nice about this interface is, so these are the individual commits that I made. If I click on any one of them, this is telling me what happened in that particular commit. So it looks like I actually, the red means you deleted something. So it looks like I deleted some files. The green means you made some additions to a file. So I made some, I've made some additions and deletions to particular parts of this file. Okay, so again, that's a nice graphical illustration. You can get the same from the command line by using git log with some other options added onto it, but I think you'd appreciate that. Once you get used to Git support within VS Code, it's much easier to play around with it, really. But that's the basis of all of this anyway, is git log. You want a log of the Git repository, whereas Git status is all about the status of your working directory. And then I'm illustrating in this slide, and I think on the next one, what the output from the command line is with git log. So we need to look at that in any detail. And there are lots of options available too. You can imagine in a project that is spanning a year or longer, your git log is going to be extremely long. So you can do things like say, give me a report on the repository between certain dates or after a certain date. So there's a lot of flexibility built into it. So it's a very good kind of search tool available to you. Right, that's the summary.